Hi everyone, welcome to tutorial 30 of our Introductory Python for Image Processing tutorial series. Now in this tutorial, I'm going to provide a quick overview of opencv library. In fact, explain a few basic image processing tasks using opencv library. In the previous tutorial, in the last tutorial, tutorial number 29, I covered the overview of Scikit-image or the basics of Scikit-image. And these are the two primary libraries for image processing, Scikit-image and opencv. Now, opencv is an amazing library for machine vision type of applications. It works great on images, videos, especially real-time videos if you want. So there has been a lot of development in opencv, and primarily I think it originally started off as a C or C++ library, but then of course there are Python, it's available in Python for us to use. So let's jump into Spider so we can have a look at a couple of basics of opencv. And again, as I mentioned in the last tutorial, I'm going to explain more about opencv in the upcoming tutorials when we focus more on the application or the task rather than on the library itself. Meaning, if we want to do Gaussian smoothing or edge detection, then we'll find the right libraries, whether it is Scikit-image or opencv. So for now, let's focus on opencv. And as usual, I have written a few lines of code earlier, so let me go ahead and try to copy and paste and explain them line by line. So I took some notes to make sure I talk about it when I'm explaining this. Like I already mentioned, it's a library for programming functions for computer vision, okay, opencv. And let's jump in and see. Now, first of all, to install opencv, go ahead and pip install opencv-python. Okay, just like Scikit-image, to install it, you do scikit-image, but when you use it, you use sk-image when you import it. The same thing with opencv. When you install it, pip install opencv-python. But when you import it by calling import cv2. This stands for opencv2. Okay, so cv2. Now, to read an image, again, I covered reading images in my previous topics, so I'm not going to dwell too much time on this. So to read an image, we are going to do cv2.imread and whatever that image path is, and a value of 1 means read it in color. Okay, so just so I show you this, under images, I should have an image called rgby.jpg. Okay, this is what we are trying to read. And color is BGR and not RGB. And it's very important to mention this because if I do PLT, I haven't imported that library. So let's go ahead and do that. From matplotlib, import pyplot as PLT. Okay, so once we do that, now we can actually plt.imshow. What do we want to show? img. Okay, let's go ahead and run these lines for now. So now you can see my original image is this. My original image is this. What it's showing me is that. That means my blue became red, my red became blue, green is green, my yellow became whatever the opposite of red and blue mixture. Okay, so this is a key thing that you have to remember about opencv. It reads images as BGR and not RGB. If you want, you can change it. You can change it to BGR to RGB, and then if it makes you comfortable. But this is okay. I think all we're trying to do is do image processing, and if you stick with opencv, you're fine. Okay, so that's one note, and let's go ahead and resize our images. Okay, so the way you resize image in opencv is cv2.resize. That's it. Okay, of course you can import resize from opencv here, but this is also okay. So I'm saving this resized image as resized, and this is cv2.resize. And what are we resizing? This numpy array called img. And go ahead and look at the documentation for resize to see what actually goes in as arguments. For example, fx and fy are by what factor do you want to resize it? So I'm going to resize this by 2 times, which means my output image is going to be 2 times bigger. Okay, when we are stretching the image, how do you want to fill these extra pixels that we are adding? By interpolating using intercubic. Okay, So that's what this line basically means. And then I'm going to show the original and resized pic. So let's go ahead and run it. So here is my resized picture, and here is my input original image. So this is 2 by 2, 4 times larger than my input image. Okay, so this is how you resize. And again, I'm using not PLT, but I'm using cv2.imshow to have a look at these images so I can see them clearly. Now, by the way, when I actually open it in opencv, the colors are correct colors here. You see, they're not like these colors. That's because I'm using opencv, and opencv knows how to understand BGR images. That's why if you stay within opencv, you're fine when you're dealing with color images. But color is just relative, right? I mean, if color means something to you, then pay close attention. Okay, so the next step is, let's go ahead and do something fun. Okay, so what is fun? Let's read this image, this RGBY image. Let's stick to it. And then let's look at the shape of this image. Okay, so let's go ahead and print the shape. The shape of this image is 586 by 415 by 3. Okay, now if I just look at the top left corner, now I can just do 0 by 0, which is always top left. Okay, so print top left, and then it's going to print the values of pixels in the top left. Okay, the values are 38 and 3. So it's mostly blue. Again, BGR. It's 3, value of 3 in green and 0 in red. Okay. Now here you can actually put, 586, 415 or something, but let's run this top right line right there. So top right is, what is our top right? Yellow. Yellow is what? A mixture of green and red. That's what this is, and no blue contribution. So almost equal amount of green and red, 20 and 21. That's what top right is. Bottom left, hopefully you can guess what's going to happen. A value only for green, 0, 55 and 0, and bottom right is red, right? A value of 250 for red and very little values, small values for, these are not pure red. This is apparently a little mixture of green and blue in that channel over there. So this is how you can actually extract a value at a single pixel by pointing at that specific pixel. Okay. So now let's increase this fun by splitting the channels. Okay, so let me delete these, and in fact we can just delete all of these and just use this. So now I'm actually calling my blue image as my original image with all the values from X and Y, right, or Y and X, right? So our image is size 586 by 415 by 3. So I want all 586 pixels, all 415 of these, except only from the first channel. And what is our first channel? Blue, with a value of 0. The second channel is green. Okay, and the third channel is 2. In a NumPy array, again, go back and look at my NumPy array tutorials. I'm actually looking at, again, if you are new, I think it's worth mentioning it. So channel number 0 is blue, channel number 1 is green, and channel number 2 is red. So if you look at this right there, 586 by 415 by 3, which means it has 3 images. Okay, I'm stressing this quite a bit because it's very important. It has 3 images. Think of this as 3 images of each 586 by 415 with blue, green, and red. So all I'm doing here is splitting them into blue, green, and red. That's it. Okay. So if I run these 3 lines, now I should see additional elements here called blue, green, and red. Because I'm extracting them, now I don't have my, look at the size of my NumPy array. It's 586 by 415. There is no third number there because now this is just a gray image, right? When you split channels, what happens? It's just a gray image. That's what the blue channel is. So you can go ahead and look at this if you want. So do I have it? Yeah, let's go ahead and look at, in fact, red image may not be fun. Let's only look at, yeah, let's go ahead and look at this and see how it looks like. So red image is on the right hand side. If you look at our original image, the bottom right is red and yellow has red contribution, right? So that's what this red image is. Now if you plot the blue pic, you can see, what did I call it? Well, this is the title, and let's actually plot blue pixels here, BLUE, and top left should be blue, and everything else is dark. Okay, bottom right is showing a little bit of blue. That's because, you know, we have a value of 16 around there. Okay, so that's what that's how you can split the channels. Now, again, think of this as if you have for example, a nuclei image, you know, osteosarcoma image. In fact, we can do that in one of our upcoming tutorials. But then if you have RGB channels, you can just extract the DAPI channel and then just do nuclei counting. So that's a great example here. Now, I showed you the long way of doing this, but there is a built-in function in Python to actually split the channels. It's just dot split. So let's go ahead and use that single line. I showed you the NumPy way because that teaches you how to think from a NumPy array point of view. But you can easily split by just doing dot split, cv2 dot split, which means the output is blue, green, and red. I'm assigning them to BGR here. You can just type blue, green, and red if you want. And now let's just go ahead and plot the green pick. And when we open it, so here is the green. On the top right, yellow, and the top bottom, let me open this. So you have the green bottom left and top right. Okay, so that's what it's actually plotting. And we are splitting the image over there. So this is very easy to do with just one line. And once you split it, why do you want to split it? Sometimes I just want to split these and then just work with my blue image, do some processing to the blue channel, and then merge all the channels together. How do you merge the channels? Pretty much the same operation. Instead of split, it's going to be merge. Okay, so it's going to be merge right there. So image merged is cv2.merge bgr, and let's just say merged image pick. It should be img underscore merged, and it should look pretty much the same as your original image. So this image is nothing but where we took an input image, split the channels, merge the channels again, and this is what you're seeing. Okay, again, a few things that you can do in opencv. Finally, let's end by looking at a built-in function in opencv, just like we have looked at Gaussian smoothing and Sobel filter in Scikit-image. Let's just look at canny edge. Let's actually delete all of that. How to do canny edge detection. So to do that, again, I'm reading a input image as grayscale here, and then I'm applying cv2.canny because canny is part of opencv. Just cv2.canny, and again, I don't want to explain details because I'm going to spend some time talking about this. But these are basically the minimum and maximum values to apply onto this image using canny. And then I'm just showing you literally one single line to perform canny edge detection. That's it. Okay, so let's go ahead and run it, and we should see the edge detected and the original input image as grayscale. And here is the edge detected. Of course, this can be better, but you can see how easy it is to apply these filters in in opencv. And also in Scikit-image. So in the next tutorial, let's cover a different topic, but the plan is to use Scikit-image and opencv for various tasks in the next series of upcoming tutorials. So please stay tuned for those videos, and thank you very much for your attention.